All right, welcome back. Once again, we were talking about linked lists, and during our discussion about linked list, we talked about various methods we have in linked list, especially the circular linked list class. This is the class we actually had constructed and discussed in last couple of weeks or so. We have 2 or 3 methods which we need to discuss in today's discussion. So today's discussion will be a slightly brief discussion, probably 15 to 20 minutes. So you'll find this lecture by itself, but it's kind of connected to our previous discussion, the previous lecture from Monday. All right, the 3 methods I would like to discuss are copy list method. That's the method I would like to start with. We have also delete node method and insert node method. And on our Moodle site, on our class demo 2, you will find these methods are already available to you. So you can actually use these methods, but I'll be exploring further what exactly is available in these methods. On this whiteboard here, I have their signatures or headers of these methods. So let's actually review this header for copy list. And I'll also show you how do you call this method, either directly or indirectly, how this method will be called from the main function. So here's the name of our method, copy list. Again, that's the method. You can call it anything you like. And this is the name of our class, circular linked list. Notice that there's a keyword here, const, which means this method is not designed to change anything. It's a constant method. Also, this method takes the data of type. That's the data type. Now, type, if you remember from our previous discussion, it's we declared a template, and the template is type, which means any data can come in. And we can use any kind of data which can be either manipulated or which can be accessed by using this type. If I have integer, I'll put integer here. If I have string, I can put string here. But making it a template type, you can declare it in this fashion, and then you can actually send any kind of data to be inserted or deleted or copied. This means reference in C++. This ampersand sign means it's a reference. What reference means that the original location of the data is being sent. So not the copy of the data is being sent, not the duplicate copy, the original address is being sent. So it is passed by reference or passed by address. That's what we call in C++. So whenever you see ampersand sign here and other places as well, whenever you see ampersand sign, it means the original data where it was declared in the memory. Let's say the data was declared in the memory like this. So that's the data. And let's say the data is, for this sake of discussion, the data is integer. So I have this integer location, and there's a pointer pointing towards this data. Let's call this one pointer is PTR, and it's pointing over here. So this location 1000 is being sent when we send as a reference, not the content itself, but the address itself. So in that way, there's no need to make a copy of the data at a separate location, so there's no duplicate copy. So original location is being sent. So when this function wants to find where the data is, it goes to the same location. It's looking at the same location. So that's where you use the ampersand sign. Although in this instance, in some instances, you can send a copy, but that's just a waste of resources, because you do not need to make copy of all the data. And this is the other list I'm sending. This is the object name for the other list. What exactly other list we are referring to? We are referring to, if you look over here, so that's where we are trying to make a copy of list 1 into list 2. So let's say list 1 was built by you during your execution of the program. You added some content in the list 1. Let's say some bunch of numbers, 5, 15, so on and so forth. So that list is already in existence, so you want to take that list, copy the entire list into list 2. So take the list 1 and copy into list 2. Now list 1 is not a simple value. List 1 is not like such as x equals to 5. List 1 and list 2 are not like that. List 1 is not simple literal value like this one. List 1 is more complex. List 1 has a lot of different things in place. List1 is an object of a circular linked list type. And we'll look into that one in a few minutes when we do the demo. But list1 is very complex in nature. It has so many different methods. It has constructors. It has a destructor. It has some private data. It has some protected data, and so on and so forth. So you cannot just say, I'm going to copy list1 into list2. You cannot really do that. It's because equality is not understood between those two complex methods. So equality and some of the other operators are not applicable. I cannot say list1 is greater than list2 because it's not like 5 is greater than 2. We are not comparing those literal simple values. We're comparing complex objects. So when you deal with these kind of objects, you have to tell your class what equality means. So you will find there's a method, very small method, which overloads an equal operator. So there's an overloaded method. As soon as we go to circular list, the first thing you will see, overloaded method. So this is the term I'm using, overload or overloaded methods. Overloaded method means that method, in this case, I should call it overloaded operator. So operator overloading. So what it means is that operator, like equal or not equal or greater or not less than greater equal, all these operators, all the relational operators, there are 6 of them, and some of the other ones such as assignment operator can be overloaded, which means the program can understand that equality can be applicable for these objects. So these are my 2 objects I created, list1 and list2. These were created at the time. If you look at the main function, at the top of the main function, that's the first thing I say, circular linked list, list1, comma, list2. And when you create these objects, it goes and looks for a matching constructor. It says, do you have a matching constructor? It says, yes, I have a matching constructor. Then it initializes that particular object. So once your object has been created, then it has access to all the public methods of that class. Right? So that's what it means. So when I say copy list, and list is a complex object, so I should be able to apply the copy list. I should be able to send this list1. So literally this list1 is being sent, and it is being captured here. Other list. List1 is being captured here. So this is where the list1 is coming in. So I'm sending list1 so it can be copied, and we can make a duplicate copy to list2. Why do we need to do so? Because we are just testing this program, but in real world, probably I want to make a copy and modify that copy. Similarly, we have the second method, and by the way, notice that all these methods, these are void methods, which means they are not designed to return anything. So this is, if you are looking at these method signatures after some time, you can actually return, these methods can return something back to you, or these could be void methods. So these methods, in our case, are void methods. They are not designed to return anything back to you. They can return any data type. They can return objects as well. So our delete node method is designed to delete piece of data. Let's say we have added some data, and we would like to delete that data from that node. So I want to delete that node. The node could be the first node, node could be the last node, node could be the middle node. So I have to search that node in order to delete it. I do not know where that node is. So my delete function should be able to search that data, search that node. If the node is captured, delete it. And once we have deleted that node, make sure that our links are connected correctly. So let's say that's a middle node. I want to delete the middle node. So then my first node should be able to point to the following, the third node. So this delete node takes what? It takes an item. What type of item? In this case, it takes a number. For our program we have, it takes that number. So number is being sent as an argument. Whatever the number is. So number will be captured here. And we are sending as an address, as a reference, which means I'm not making a duplicate copy of number. I'm sending the original location at that number, just like I indicated earlier. and it is being sent of this type. This type means this could be any kind of data. It could be a character, could be a string, could be a double, could be some other type of data. So it doesn't really matter. I'm not saying it's an integer. It could be of any kind of data. And it is a constant, and that's how the delete node is going to work. And same thing with our insert node. Insert node also takes one argument, which is a number in this case as well. So I'd like to insert that number right here. So number will be captured. It is being captured as a reference and of any data type. So these three methods, this is what they look like. And I'm going to go and briefly talk about their bodies and their the code inside each one of these methods. That will be our first next step. All right? Let's go and get our program up and running. All right, so it will take a minute or so. While it's getting ready for our online students, I'd like to show you that all of the videos are available, and I can actually see who is clicking on these links, who's watching, how many of you are spending time. So when you send me a question, and the question shows me that you are not really understanding any content, so I can actually see if you really spent time on that particular link, if you were watching that link. So please find some time to watch those videos. If you find better videos, you are searching on YouTube, you find better videos from one of the top university, feel free to send me those videos, and I'll be more than happy to place those links on our video as well. So here are the links right here for our last lectures we had. We have 6 of these videos, and I'll be adding lecture 3 right underneath here, especially for our online students. So you'll find after today that lecture will be available to you. So, and we'll come back and revisit this our Moodle site in a few minutes. But let's look at our copy list. So before we go to copy list, this is what our main looks like. In our main, that's what we are referring here, list 2 equals to list 1. So I'm trying to make a copy of list 1 into list 2. As indicated earlier, these are objects, and objects do not really understand some of these operators. And as you can see, list 1 and list 2 are objects. These are objects. You will see right here. So these are objects created early on. What type of object I created? For my demo, I created integer. For our project, we need to think about it, creating maybe characters, strings, and maybe double as well. If you want to try doubles as well, that would be nice. So here, by default, in our program, I'm creating integers. So I'll demo that how you can actually switch it to other type of data as well. So when I like to copy it, we have in our program, there's a private data member, and that is called copy list, which I have already discussed with you. Let's look at this copy list program or copy list method. I think you can see on the camera. I think, let me move this one a little bit more. Okay, so here we have 3 of these variables. One for new node to create a brand new node. If I want to make a copy. One for the current pointer. So these are 3 pointers. I know these are 2 pointers. These are the pointer variables by looking at the asterisk. So I have 3 pointers. One for temporary, one for current, one for new node. So when I want to make a copy, the first thing I'm checking is if the first pointer is our pointer in the protected data member as a protected data member. If I'm checking if the first is not null, it means the first is already pointing towards another list. First is already assigned to another list. If that's the case, I want to get rid of the previous list. I want to clear the previous list. That's what I'm checking. If the first is not null, it means first is pointing towards something other than a null, like some another node. I'm going to clear that list, and that's what I do. I say clear, destroy that list. And we talked about destroy list in our last lecture as well. Okay, if that's not the case, it means we come here if other list dot first is equals null. Now other list is list 1. Other list is which is coming in, which is being provided to us. That's the list we want to copy to our new list. So that's our other list. So I'm checking if the other list dot first is null. What exactly that means, guys, in plain English? What exactly this line of code means? Other list dot first equals null. Yeah, other list is empty. There's no data. If that's the case, you want to check these conditions. If that's the case, guess what? My new list, which I'm trying to generate, make that one null and count equals to 0, which means my new list will be null as well. So my first pointer in my new list will be pointing towards null. It's not pointing towards any node. All right, so if we don't have this situation, if we don't have that situation, then we'll start copying the content. Let's see if I can quickly scroll down. All right, I think this view might not be that practical. Let's try to find a different view. Yeah, I think that's better. So if the first two situations, if my existing list and incoming list, they are not null, they are okay, then I can move on to this one. Then I can say, okay, if that's not the case, my incoming list, the incoming list which I send as an argument, the first link, which means where it's pointing, the first pointer of that list, the link of that one, assign that to my current variable of my local list, And whatever the count is, let's say it has 1 or 2 or 3 or 4 nodes, whatever number of count or number of nodes it has, assigned to my local variable. So whenever you see other list dot, it means we're referring to the incoming list which came as an argument. All right, so we set the counter, we set the current pointer. Then I'm ready to create a new node because I know there is some data in the other list. I would like to copy the data piece by piece. I would like to take each node, make a copy to the current to my local node. So here I'm creating a new node, and I'm assigning a pointer temp first. So temp first is a temporary variable. It's a temporary variable of pointer type. It's going to point towards a new node. So new node is being generated, so I can point towards to this new node. Then I say, okay, whatever the info you provide, whatever info you have, assigned to my temporary first info. So what I'm doing, I'm taking a copy of the first node, copy of the data of the first node, assigned to my local node. You guys are okay with that? Okay? No? Okay. So take the first node, the data from the first node, info from the first node, assigned to local temporary node. And then move my pointer last where my temp first is. Because maybe I want to use temp first for creating additional nodes if the additional data exists. So I'm actually leaving my last pointer, and probably I want to move my temporary first to the next one. All right, so in the next couple of steps, what we do here is we move our current to the current link. So we are moving current to the next node, and then we are checking if the current, my local current, is not equal to first, which means it has not gone through the entire cycle, which means the other list has not ended. If that's the case, I'm going to stay in this loop forever until I find the first one. First one is the other list is a circular list. So after the first node, second node, third node, fourth node, at one stage it's going to come back to the first node. So I'm checking if my current variable, which will allow me to traverse this list, if they are not equal, then stay in this loop, so I can copy each and every node to my local area. So I generate a new node here, just like I did it earlier. New node is being created. I take the info of the current, paste it in my new node info. So I copied another node, and then I actually move my last link to new node. So I'm moving my last link, and last equals to new node. So last is also pointing where the new node is, and move my current. This is key here, guys. So move my current. So when I move my current pointer, then I come back here and check again if the current info is being copied successfully to the new node. New node is being generated right there. New node is being generated right there. So what it's going to do, it's going to basically go each node of the other list and assign to the local list. Each node will be copied in that cycle. Then at the end it will check right here if the temp first equals last. It means we have reached the last one. First equals to temp first. We are just verifying they are actually the same. If that's not the case, it means more data needs to be copied, and then it creates a new node, and current info will be copied to the new node, and we go through the same cycle. Okay, just wanted to share this with you that if you want to check this one, like I stated in last discussion, you want to put a system pause. You want to put a system pause here, maybe a system pause here, just to see what the results are, how it is being copied from one line of code to the next line of code. Now we do something similar when we do the delete. And here's our delete. With something similar, the only difference is in this time we are not copying, we are deleting the nodes. And we talked about destroy function last time. And here we are going to use some kind of similar method. So incoming data, this is the data I would like to delete. First, I also need to figure it out where this data resides. So I have a couple of methods here, a couple of pointers here. One is current, one is trail current. Current is going to move forward, trail is going to be right behind the current. The reason is because you want to have two pointers, so when you delete something, a node is being deleted, you can tell exactly where you are by using those two pointers. And again, we check if the first is null, nothing to be deleted. There's no data. So you just want to check that one. And initially the found is false. It's a Boolean variable, which means nothing has been found. And our trail current equals to first. So wherever the first is, my trail current is right there. Okay. So my trail pointer is where exactly the first is. Assume the first is the one which is pointing towards the first node. And the current one is right ahead of it. So my trail current is behind it. The current is the right next node. That's what it says here. Current equals to first link. So current is one step ahead. And then we check a condition here, a couple of conditions. If not found, let's look at this one. So found is set as to false. It is set to false. So not found is if it's true, and current is not equal to first. Remember, the current currently is pointing towards the second node. The first node, that's where the first is pointing. So current is at the second node. Because it's a circular linked list, you are checking, have you gone through all the nodes and you're pointing towards the first node? Answer is no, not at this time. So that's what we are checking. If the current is not the first, then stay in this loop. So one of these conditions, if these two conditions are true, stay in this loop. So of course, found is true. Found is not false. It's true. So this is true, and this is also true because current is not equal to first. Then we say, okay, let's see if we can find the argument which we sent from the main function if that one matches with the current info. Remember, the current info is pointing towards the second node, so we are saying, do you match? Are you greater or equal to? If you do, change are found to true. If not, move the trail current to the next node and move the current to the following node. What it means is take the trail current, move it to the second node, and take the current pointer, move to the third node. So we are just gradually ensuring that two of these pointers are moving one step further. If one of these conditions are true, if the current info is greater or equal to delete, then we have something to look at. So let's see what happens underneath here. Then we check again, is this the last, if the current actually has also reached the first node? If that's the case, then first info equals delete. It means if the criteria was the current actually has reached the first, it means it went through the entire circular list and reached the first one, then the first info, if that's the match, if they match, the first info matches, then we want to get rid of the first node. If not, then we'll see what will happen in that case. So first equals to first link. So basically take the first pointer, move to the next node. Move to the next node and delete the first null. First equals to null. If that's not the case, if the first one is not the case, trail link equals to current link. It means if this did not happen, this did not happen, if first equals first link, so let's go back here. I lost my trail of thought. So first info is not the item you want to delete. If that's the item you want to delete, the first will move to the next node. And if that's not the case, the trail current link will equal to current link, which means now trail and trail link is going to point where the current link is pointing. And the first will move, yes, the first will move where the trail current is. So you're moving the trail current because you want to get rid of the first node, and you will point the first where the trail current is. And then delete the current. Delete the current, that's where the current currently that pointer is, and decrement your count. So you're decrementing your count. If that criteria does not match, you did not find anything to delete, you simply tell the user, sorry, there's nothing to delete. I didn't find the match. And we'll do almost something identical for insert as well. But there's one more scenario we have to check. Previously we checked if the first and the current, they matched. If that's not the case, if the current pointer info matches with the delete item. If that's the case, it's somewhere in the middle. It's not the first one, it's somewhere in the middle, maybe the second or third or fourth node. That's the case, then I want to move my trail where my current is pointing. I want to move my trail to the following node. I want to decrement my count and delete my current, because current is the one which needs to be deleted in that case. Delete that current and decrement. If that doesn't happen, it's not in the middle, simply tell the user there's nothing to be deleted. Okay? Now, let's actually, I'm going to demonstrate something for you. This is the program we have. This is the program we ran yesterday. So in this program, I think you can probably see. Let's see if you can. All right. You can probably see right there. So this is the program we ran yesterday. It might not be that visible for our online students, but at least you can see it says enter number ending with point minus 999. You can actually have any kind of terminator in your code. So it doesn't have to be minus 999. It could be something else. So if I enter some data here and end with minus 999 and hit enter, So it generates that list as we demonstrated yesterday or day before yesterday, 4, 6, 18. There are 3 items. Then it's asking to be searched. So we can search something in the middle. We can search it. It searches successfully. Then it says, what do you want to delete? I say I want to delete 6. And then it deletes that item from the list. So we delete that item 6. Now we have the remaining data is 4 and 18. 4 and 18, it shows the list one is has removed that item. So that's the delete option. Now question is, what if I want to do the same thing with other types of data? So again, I spent maybe 10 minutes on this program just to show you how quickly you can develop it. And that's what I want you to do for this project as well. So you should be able to add other types of data as well. So when I run this code, so you want to give a nicer menu. Here the menu I have is not that great, but this is what it looks like. Type 1 for strings, 2 for characters, and 3 for integers. You should be able to give a nicer menu. You can create a nicer menu, much nicer if you spend maybe 5 extra minutes on that program. So let's say I want to create characters. I would say 2 for characters. So it's asking, okay, enter characters ending with X. Again, you don't need to say X. If you have a smart program, you should be able to end with some special keys, maybe something else. Come up with a solution. Maybe some, if you know how to use some of the keys from the keyboard, if you can find the ASCII value for escape or some other characters, you can easily find it. If not, then just use a simple method to end your whatever data actually has ended, you can end it with that particular character. So here I want to give some characters here. I'll give uppercase and lowercase mixed characters. So F, uppercase K, Y, uppercase Y, lowercase p, lowercase q, uppercase A. So notice that there's no real sequence in these characters. Anybody knows which has the higher, which has the, we have ASCII values assigned to each one of those characters. Uppercase characters have smaller ASCII values versus lowercase characters. For example, uppercase A has an ASCII value of 65. Lowercase a has a value of 97. So it's going to do the sorting, ascending sort, based on which characters it sees. So if you see lowercase a comes after uppercase a, that's logically that's correct. Okay. So I have these characters. I want to end this one. So I would like to end with X, and it says, okay, these are your characters. Your list one is A, K, Y, and because these have the higher numbers of ASCII value, that's why you see F, P, and Q afterwards. But everything is properly sorted. So that list has been generated. And it tells me there are 6 of these characters. 1, 2, 3, 4, 5, 6. Now, question for you guys. Did I change my circular linked list class? Not at all. How come my program is able to handle characters instead of numbers? Because I used a template type. So type means that any kind of data can be accommodated. So if I don't use as a template, then I have to recreate this whole class. I have to copy this whole class, make a copy, change into characters or other types of data. So in your program, when you work on this assignment, do not change your class. No need to touch your class. The circular linked list, which is already available on our Moodle site, also for our online students, you don't need to change your class itself. Class is already available to you on our Moodle site. All you need to do is that you will be able to figure it out how to modify your program at the main level, or maybe create a function at the main level. All right, so if I run this program, and you should be able to run this program in infinite number of times. So you can use a simple while loop and just run this program many times. So if I run this program once again, this time I'm going to try to use strings, and I'll put some strings here. And let me put another name here. Let me put PCC here. Let me put a lowercase name here. How about spaces? Do you think I can handle spaces? Strings contain spaces. So what if I say CS22 is the best class ever? So I have something like that. I would like to put another one here. Don't take dance classes. I know it's going to make you upset, but I'm just throwing it there. And one more. Let's say we have meet. I'm going to put your name there. Okay, and I'm going to end with X. So here's my data. I'm going to show the data to the students first. So here's my data. So in my data, I have few characters. Hopefully you can see it. You can see it right there. So few strings, not characters, strings. My name, Mary, PCC, Jane. One sentence here, another sentence here, and another student's name. Then I want to end with X. So if my program is working fine, it should be able to pick up and figure it out how to place each one of those strings. So it says CS22 is the best class ever. Don't take dance classes. Mary, meet, PCC, Tahir, Jane. So based on its understanding, it placed all the data in the right place. So this is one string, this is another string, this is another string, this is another string. Now why this particular sentence comes later? Because D has the higher number for ASCII value as compared to C. And M has a higher value than D. And this A has a smaller value than E. So that's why meet comes after Mary. And P, of course, comes after that one. T has a higher value than PCC. And lowercase j has a greater ASCII value than uppercase j. So here, I'm stopping my program, but your program should be able to search and should be able to delete and should be able to copy, which means we have these methods already in place. So you can copy list 1 to list 2. You should be able to ask the user, what do you want to search? You should be able to ask the user, what do you want to delete? You should be able to go through all the steps. Okay? You think we can do it? So I see a lot of yellow, blue faces. So not happy. We can try. So what we can do, we don't have to change anything in our circular linked list class itself. We keep the class the way it is. How many of you already finished it? So 1, 2, 3. So you already have finished it. I remember Robert came to me on Monday. He wanted to ask me a question. I ignored him. Robert, didn't I ignore you? And that was intentional because, and Robert, you figured it out, right?
Oh, yeah, it took me like 10 minutes.
Yeah, so sometimes it happens you're talking to yourself because we as humans we like to talk to ourselves just to figure out the problem or solution. And it's not a bad idea. So my mom used to say, if you do not find to talk to anyone, talk to a wall. And I cannot tell you how important it is to discuss these kind of issues with somebody else. What it means is find somebody to discuss. So sometimes you must have heard speaking it loud. Sometimes you're speaking it loud. What Robert was doing, he was just speaking it loud. And he said, okay, he's standing there. Let me see if I can get some tips from him. I just ignored him. I said, you know what, you can do it. So, and he was able to do it. Same thing with you guys. You can do it. It's just that go with the characters first. Or even if you want to make it simpler, go with doubles first. Go with double and see if you can figure that out. For our online students, what exactly we are doing, which project is due, let me show you one more time then I'll stop. So in this project, and hopefully you can see it here, in this project, we'll modify our existing circular linked list program. We do not modify the circular linked list class itself. Leave the class the way it is. Leave the class alone, but we'll be modifying our main function. And currently our program is designed to take integers, so we will try to add characters and strings and maybe doubles if you can, and see if we can add these additional types of data to our existing linked list. And that's what we'll do along with integers. The current demo program accepts only integers. So you would ask the user to select what type of data he or she wants to add. So I recommend, if you are just starting, also for our online students, try the double data type. That's the easiest one. And you don't have to make a lot of changes into double. Just switch your integer into double and see if you can fix it. If that works, then you can very quickly move on to characters. So to get the full credit for this assignment, these are the three things I would like to see at least. Whole numbers, which we already have, single characters and strings. If this is the first time you're using C++, I recommend you include a string library. So where you have include IOStream, just throw string library over there as well. So if you scroll up, so originally we didn't have the string library. For our online students, please include string library as well. So this will recognize the strings are in place. If you don't have the string library, it will tell you that it doesn't recognize strings. And how do I declare my strings? Again, this is the first time in C++, especially for our online students. You can declare your string in the main function right there. So here it is, string name. And you can initialize it. This is how you can initialize your data. This is how you can initialize your characters. You can also initialize your numbers. And I have some kind of local variable choice or selection, just to ask the user what choice they are planning to make. Choice 1, choice 2, choice 3, choice 4. So based on the menu option. Okay, so declare a string library, include a string library, declare a name string variable, and for the starters, I do not want you to use Getline function. I know if you Google on it and you say Getline function can capture spaces, like I demonstrated I was able to capture spaces. For starters, no need to do that, because Getline function is a little trickier because it also accepts the enter key. It grabs the enter key as well. So it might confuse you. So just use cin object. But if you want to use the Getline function, I'll very quickly show you. Actually, I'll show you right here. So if you want, I don't want to show you this. I want you to figure it out. But I'll show you on the board. If you want to use Getline function, so the Getline function, I hope you can see it. Getline function works this way. The name of the function is Getline cin, comma, name of your variable. Let's say the name of your variable is called name or names. That's the name of your variable. So any kind of data which is coming in, let's say data is coming in, Jane is a student. If that's the data, so this entire string will be captured including spaces in Getline. Now, I recommend this after you have already completed everything. But if you want to keep it simple, just use cin. Cin will be easier, but cin only captures names like Mary. So cin does not capture spaces. Okay? So cin does not capture spaces. So just keep it simple initially. Now, however, if you have been taking some data before, let's say right before Getline, so let's say user asked you what choice would you like to make, choice 1, 2, and 3. So initially your program will say, what would you like to select? Integers, doubles, characters, and strings. Let's say you say choice 3 for strings, and there's an enter key. Enter key is a hidden key. There's an enter key here. So this choice will be saved in a choice variable. So this number 3 will be saved in a choice variable. However, this is what the buffer looks like. This is the buffer. This is a buffer. And let's say you want to plug in the word Mary here. Because after you select choice, then you say, here is my string Mary. This is what happens, guys. So if I can get your attention, this enter key will be accepted in case of Getline. This enter key will be added to the names variable. And you'll scratch your head and you'll say, what happened to Mary? Mary is still sitting in the buffer. It is not being processed. It's still waiting to be processed. So that will confuse some of you. So that's what I said, just use cin, because cin will ignore the enter key. And it will move on to the real data, which is Mary in that case. So how do you take care of that issue? So you need some kind of dummy variable to clear the enter key. So you can use a dummy variable like this. You can say char, and let's call it dummy. And you can simply say cin.get dummy. Now what exactly that means? It means this is a variable which has no purpose in my program, but I just want to clear that enter key because I want to use getline. So then this enter key will be accepted in this dummy variable, and then it will be discarded. Then this value, if you do that way, this value will be moved on to the names variable. Anything I stated in the last 2-3 minutes, ignore it. Don't do it. Don't do it. There'll be more questions than what we can afford right now. So just use cin. Don't worry about spaces. Just use cin. Keep it simple. Now some of you already have finished it. Then I recommend then you go to the next level. See if you can use getline and start processing spaces as well. For other individuals, no worries. Just use cin. Okay? All right. So that's our discussion for today. And for our online students, I would like you to go ahead and read chapter 17, especially the discussion on stacks. We'll be starting stacks on next week, starting next Monday, and I'll be spending the entire next week on stacks. Then the chapter 17 is divided into two discussions, two topics. One is stacks and one is queue. The following week, we'll be discussing queues. Once we are done with stacks and queues, this coming week and the week after, we'll be taking our exam based on chapter 16 and 17. All right, guys. Again, once again, the reminder is this project is due by October the 8th, which is this coming Sunday. Hopefully, we can finish this project on time. This project, the main purpose of this project is that you understand how to use your Visual Studio, how to include your project in Visual Studio, how to run that Visual Studio, how to modify a program here and there. So the project itself, we are not really touching the class, you're just using an existing class. And this is not something unique in advanced coding or in object-oriented coding. In object-oriented coding, we use a lot of existing code, existing classes, and we just instantiate those existing classes. So this is something part of learning as well. All right, I'll see you guys next week.